Hi, I'm Nicholas. I'm a senior technical animator, and this is the first in a series of tutorials that are released through 2023, focusing on real-time characters and using real-time techniques while performing motion capture in Unreal Engine. In this tutorial, I'm going to show you a dynamic look at target behavior using a Unreal Engine 5, a MetaHuman, and an iPhone. So, let's start. In order to get this behavior, we'll need four things: the raw data from the iPhone, the location of the lookout target, a modified ARKit Pose Asset, a simple scene component as a reference, and we are going to use the MetaHuman Blueprint to get them. We need a scene component, which we'll call third eye, as a child of the face skeletal mesh, parented to the head joint, placing it at the nose bridge. We then add a sphere as a child using a 0.025 scale using a white material, and then another sphere as its child, this time with a scale of 0.4 and Y set to 40 with a black material. The spheres are just for visual debug, since we just need the third eye rotation values. Inside the event graph, we use the tick function and add a simple if condition, which enable the lookat behavior. We then use an evaluate LiveLink frame, where I select the iPhone, and from the data result, we can get 4 getPropertyValue nodes. We get the property names from the left eye only from the face anchors in ARKit, so we need to use eye look up left, eye look in left, eye look up left, eye look down left. Then, for each, we use a map range clamped in order to rescale the 0 to 1 values to specific eye rotation, which we can get from the ARKit Pose Asset by selecting the left eye and then applying one of the poses. Please note that for the lookout in, you need to invert the minus values, as shown on screen. Both the lookouts in and up-down are then connected to a select float, which takes care of sending the plus-minus data accordingly to the eye rotation. The two floats are then saved, and the third eye uses a set relative rotation node, so that it will mimic the left eye behavior using raw data from the iPhone. This data will later be used to understand if the eyes are looking or not towards the lookat target. Now let's add another scene component, and we'll call it third eye lookat, also child of the face skeletal mesh, and parented to the head joint, placing it above the third eye we created before. We also add an arrow as a child using a 0.1 scale, and also a white sphere again with a 0.025 scale, and a smaller black sphere as a child with a 0.4 scale. The third eye lookat, as the name says, will always look towards a target, and in order to do so we need to get additional data. So going back to the event graph, using a getActorOf class, we need the actor location of the lookat target, which is an empty blueprint, and in the outliner we can see that is a child of the camera. Then we use a find lookat rotation node, using the third eye scene component world location as a start, and the target actor location as the target. We then set the third eye lookat world rotation using the data from the find lookat rotation. Now we have both real-time data from the third eye and the lookat data from the third eye lookat. But what logic can we use to understand when the real-time eyes are looking more or less towards the camera, so that we can then switch between the two data? We use dot product. Using the third eye right vector as the first input and the third eye minus the lookat location, they're normalized and set as the second input, we get the dot product. But we also set a threshold where if the dot product is equal or more than 0.1, we use A, which is the lookat data, while if less, we use B, which is the real-time data from the iPhone, saving it as a float called lookat alpha. Now we also need an additional scene component, child of the face skeletal mesh, parented to the head joint, with the same location as the third eye lookat component. This is just a static axis reference that we're going to use in a bit. A print node is added for the dot product value debug. Since we got the third eye lookat rotation as word, we need to convert it to local using the inverse transform rotation node, where we get the transform from the head rotation reference and the rotation from the third eye lookat. Each value is then plugged into a map range clamp node, where the data is rescaled to be 0 to 1. Note that for the lookup down, because of the third eye lookup orientation, the range A values starts from 90. Each float is then saved. Inside the face animation blueprint, we need to update its logic, and in order to do so, we also need to create an updated version of the ARKit Pose Asset, which we'll call _no_eyes. We duplicate and we need to remove the left, right, lookout, in, up, down data, since we're going to use our own. Inside the anim graph, after the LiveLink pose, we need to save a new cache pose. We'll call it pre-ARKit mapping. After that, we also duplicate the ARKit mapping node, but we use the updated version by selecting the _no_eyes pose asset. We then get a modify curve node, and if we right-click on it, we can see that we can use add curve pin. So we add all the left, right eyes, look left, right, up, down floats. We then create 4 floats, each one connected to the left, right eye animation curve. Before the ARKit mapping nodes, we use the cache we previously saved, and then we connect the original ARKit mapping and the modify curve node to a blend node, creating a float for the alpha. We then connect the blend node to the existing modify curve node, compile and save. Going back to the MetaHuman Blueprint, we need to set the floats we just created inside the face animation blueprint. So we cast towards the face animation blueprint, and we use the lookat floats and lookat alpha to drive the eye's behavior and blend. In my setup, the camera is placed in front of the character, where only the one on the right has the lookat behavior enabled. On the top left, you can see the debugged.product value. If we test the behavior, we can see that whenever we look towards the camera, the eyes are properly locked towards the camera, while if I look around, you can see the normal eyes behavior. I set keyboard shortcuts to enable the third eye visualization, so here is the raw data from the iPhone. While here you can see the lookat data. And using the dot product, we are switching between the two in real time. In this example, I have a single camera, but you can easily add 2 or more and switch the lookat target. Or if you have a virtual camera driven by a live tracker, you can also have a visual reference in real life. Hope you enjoyed this tutorial. More focused on real-time characters will come in the near future, so stay tuned.